In this video, we'll explain how to obtain an apparent altitude. When you calibrated your sextant, if you were unable to remove the index error, then you noted the index correction needed. Note this index correction on your site reduction form in arc minutes. If you were able to calibrate the sextant, then this value should be 0. Note 0 or NA for not applicable. In our example, we'll assume it is not applicable. Next, you need to estimate your dip correction. This is simply the height from the sea level of the sextant during observations, or, if you're on land, the height from the ground to the sextant, providing the ground is level with the horizon. A good navigator has thought ahead on what this height is in calm waters, and takes sextant measurements from the same part of the ship if possible. In our example, let us assume that our sextant is 2.3 meters above sea level or above the level plane of the horizon. Often, you must contend with waves. These waves not only rise above sea level, they also have troughs between them that sink below sea level, and we need to account for this in our height estimate. Sextant measurements are typically taken at the crest or top of the waves, as this gives the best view of the horizon. Take the average height of the waves and cut that value in half. Add this to what your height would be in calm waters. In our example, let us assume the waves are 6 meters high, so we add 3 meters. Remember, our height in calm waters was 2.3 meters, so adding 3 meters, we now have a total of 5.3 meters for our estimated height. Once you have your height in feet or meters, go to the Nautical Almanac, to the first page on the right, and look up your dip correction. Note the value in arc minutes, denoted with a single apostrophe, on your site reduction form. In our example, we had 5.3 meters for our height, and we see in the dip column that this translates to minus 4.1 arc minutes. We note this as our dip correction. So in most instances, index correction and dip correction are calculated before you obtain your sextant measurement, which is why they're listed first on the site reduction form. Finally, measure your apparent altitude with your sextant and note it on your site reduction form in units of degrees, plus the fraction of degree in arc minutes. In our example, let's assume we measured the sun at 26 degrees and 18 arc minutes above the horizon, so we note this as our sextant altitude. Add the index correction and dip correction to your sextant altitude, remembering that if either is negative, you instead subtract it, and this gives you your apparent altitude. In our example, we subtract our dip correction from our sextant altitude, which gives us a value of 26 degrees and 13.9 arc minutes. This gives us our apparent altitude, commonly known by the initials HA. To test your understanding of what we've covered in this video, click this link. It'll take you to a few questions designed to help you remember these concepts. Once you are comfortable with this material, you can move on to our next video, Observed Altitude, by clicking on this link.
Oh no, I'm not a pirate, but a man.